Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, students, subscribers, viewers, and future engineers. There is another batch of problems in Engineers in Progress, particularly in clock problems. I hope that you will give importance to this playlist because this will help you enhance your skills in mathematics, in your analysis, which will prepare you in engineering life. So let's have the principles in clock problems. First, consider the clock shown. By the way, if you want to anticipate the solution to these problems, you may do so by pausing the video. For those who are already graduate of any engineering course. So that's 12 o'clock, and after 1 hour, so that's 12 o'clock. After 1 hour, this would be the movements. We'll just make it fast. So we observe that the minute hand has turned one complete revolution or 60 minutes, while the hour hand correspondingly turns only one mark, and that's 30 degrees or 1/12 of a revolution. And the number of minutes, equivalent number of minutes is 5 minutes only. So this is the final position. Observe that the minute hand has turned 360 degrees or one complete revolution, which corresponds to 60 minutes, while the hour hand has correspondingly turned 30 degrees or 1/12 of a revolution or 5 minutes. In general, if this is the reading, 12 o'clock, then after X minutes, that would be the position of the hour hand and the minute hand. So from the initial position of the minute hand to its final position that is designated by X minutes, and from the initial position of the hour hand, which is also the 12 o'clock mark, to that final position, X over 12 minutes. So that's the principle. Other important information and facts about clock problems. The minute hand, 60 minutes corresponds to 360 degrees. For the minute hand, 60 seconds corresponds to 360 degrees for the second hand. And 12 hours equals 360 degrees for the hour hand. So therefore, uh, per graduation movement of the hour hand would be, for the minute hand rather, would be 5 minutes per mark. So this is the relationship between the tangential velocity or linear velocity of the tip of the hands of the clock, and that is omega times r. You start with S equals radius times central angle theta, arc length from trigonometry. S equals radius of the circle times theta. Differentiate it. ds dt is V, and radius constant d theta dt is omega. Omega is in radians per unit time, and r is the length of the hands of the clock. So omega, angular velocity in radians per second, v, tangential velocity or linear velocity in meters per second or feet per second or inches per second, centimeter per second, whatever would be the appropriate units or given units. R, radius or length of arm of minute or hour hand or second hand in meters or feet or inches or centimeters. So let's have now this first problem. At how many minutes after 3 p.m. will the minute hand of a clock overtake the hour hand? So the idea is to draw a clock and the reading is 3 p.m. So that's 3 p.m. that our hand is pointing the 3 mark and the minute hand is pointing the 12 mark. So by principle, from the initial position of this would be the final positions of the hour hand and the minute hand. They are all together on a straight line, or that's the time when the hour hand is overtaken by the minute hand. So from initial position of the minute hand to its final position x, initial position of the hour hand to its final position x over 12. So from the figure x minus x over 12, it ends at 3, and 3 corresponds to from 12 15 minutes because per mark 5 minutes. So 3 times 5 is 15 minutes. So x minus x over 12 is 15. 11 over 12 x is 15. So x is 180 over 11 minutes, or in mixed fraction 16 and 4 over 11 minutes. So that's it for that problem. For the next problem 2, at how many minutes after 5 p.m. will the hands of a clock will be together for the first time, become perpendicular for the first time, together in opposite directions, and become perpendicular for the first time, for the second time rather. So for part A, uh, reading 5 o'clock, so minute hand pointing the 12 mark and hour hand the 5 mark. From this would be the final position of the minute hand and the hour hand. They are together for the first time. Then initial position of the minute hand to its final position x, initial position of the hour hand to its final position x over 12. From the figure x minus x over 12 equals, it ends at 5 and 5 corresponds to 25 minutes, 5 times 5. So x minus x over 12 is 25. Using your calculator, x is 27 and 3 over 11 minutes. For part B, perpendicular for the first time, so the angle between the minute hand and the hour hand is more than 90 degrees at the start. And remember that the minute hand turns faster than the hour hand. So this would be the final position of the minute hand and the final position of the hour hand, so that they are perpendicular to each other. And 90 degrees corresponds to 15 minutes. 90 divided by uh, 30 degrees is 3 marks, and 3 times 5 minutes per mark is 15 minutes. So from the figure, initial position of the minute hand to its final position x, initial position of the hour hand to its final position x over 12. So x plus 15, then minus x over 12, it ends at 5. So 5 is 25 minutes. So x plus 15 minus x over 12 is 25. 11 over 12, x is 10. So x is 10 and 10 over 11 minutes. Part C, together in opposite directions. So clock 5 p.m. Then this should be the position of the hour hand. It should be before 6, and final position of the minute hand. They are together on a straight line, opposite directions. Initial position of the minute hand to its final position, call that x. Initial position of the hour hand to its final position, x over 12. And when the hands of the clock are on a straight line, that corresponds to 180 degrees divided by 30, so 6. So 6 marks times 5 is 30 minutes. So from the figure, x is equal to, from 12 to 5, 25 plus x over 12 up to here, then plus 30 minutes. So x equals 25 plus x over 12 plus 30. 11 over 12, x is 55. So x is 60 minutes. So of course, common sense, if this 5 p.m., the next time after 1 hour, they will be opposite to each other at 6 p.m. So that's why the number of minutes where the two will be together in opposite directions should be 60 minutes. And then part D, become perpendicular for the second time. Remember that This is the first time where the two hands of the clock are perpendicular. Then for the second time, the minute hand should be ahead of the hour hand, as shown here. So initial reading 5 p.m. This is the position of the hour hand, position of the minute hand, so that they are again perpendicular for the second time. Initial position of the minute hand to its final position x. Initial position of the hour hand to its final position x over 12, and 90 degrees when they are perpendicular, that corresponds to 15 minutes. Therefore, x is from 12 to 5:25 plus x over 12 plus 15. So solving for x is 43 and 7 over 11 minutes. Then problem 3, at how many minutes after 7 o'clock will the hands of a clock will be together for the first time? First, form an angle of 120 degrees. Then another problem, it is now past 7 o'clock. At how many minutes will the minute hand of a clock be ahead of the hour hand by as much as it was behind the hour hand 10 minutes ago? So for 3A, this is a basic problem. 7 o'clock, then together for the first time, final position of the hour hand and the minute hand should be here. Initial position of the minute hand to its final position x. Initial position of the hour hand to its final position x over 12. So from the figure x minus x over 12, it ends at 7. 7 times 5 is 35. So x minus x over 12 is 35. So x is 38 and 2 over 11 minutes. For part B, first form an angle of 120 degrees. 120 degrees divided by 30 degrees per 5 minutes is 4. 120 over 30 is 4. 4 times 5 is 20 minutes. So 120 degrees corresponds to 20 minutes. So 7, and since the angle between them is more than 120 at the start and the minute hand turns faster than the hour hand, so this should be the final position of the minute hand, final position of the hour hand. Then that's approximately 120 degrees, and 120 degrees corresponds to 20 minutes. So initial position of the minute hand to its final position x, initial position of the hour hand to its final position x over 12. So from the figure x plus 20 minutes, then minus x over 12, it ends at 7, and 7 is 35 minutes. So x plus 20 minus x over 12 is 35. 11 over 12x is 15, so x is 16 and 4 over 11 minutes. Then part C, it is now past 7 o'clock. So the minute hand was behind the hour hand by the same number of minutes as it is now ahead after 10 minutes the hour hand. So I'll just designate it with data. So this should be the initial reading 7 o'clock. Then we allow the minute hand to turn. So this should be the position of the minute hand after X minutes. It is still behind the hour hand. Then after 10 minutes, it is now ahead of the hour hand by the same angular spacing theta, but theta can be expressed in minutes also. So if this is X, initial position of the minute hand to its final position X, initial position of the hour hand, which 0.7 mark to its final position x over 12. Then after 10 minutes further, so this is the minute hand, then after 10 minutes that would be the final position of the minute hand. Then the hour hand was here, then after 10 minutes it turns by that much, and that corresponds to 10 over 12 minutes by principle. And therefore, from the figure, theta plus 10 over 12 plus another theta is equal to 10. So theta plus 10 over 12 plus theta is 10. So in other words, 2 theta plus 10 over 12 is 10. Solving for theta, theta is 55 over 12 minutes. Then x, 10 plus 10 minus theta minus 10 over 12 minus x over 12. It ends at 7 mark, and 7 mark is 35 minutes. So again, x plus 10, then go back, minus theta, minus 10 over 12, minus x over 12 equals 35. So simplifying, x minus x over 12 is 11 over 12x, then 35 minus 10 plus 10 over 12 is 155 over 6 plus theta, which is 55 over 12. Solving for x is 33 and 2 over 11 minutes. So that's it for this video because it is now lengthy.